Hello friends, so this is the third lecture on logic, and before we start with today's discussion, allow me to tell you a few things. We have already discussed that what are a priori propositions, what are a posteriori propositions. We also know what is the nature of truth or falsity. Statements are true or false, arguments are valid or invalid, and there are certain theoretical things which we have covered. Today's lecture, we will start basically with what is logic, because now we have enough of background to understand what is logic. So I refrain from speaking about that, or I refrain from discussing about it in the first two lectures. We are discussing today what is logic. After that, we will discuss what is truth functionality, what are simple statements or propositions, what are compound statements or propositions, how logical connectives are defined, and what are their respective truth tables. So this is all which we are discussing today. So let us start with the first thing, that is what is logic. But before that, allow me to tell you, in logical analysis will tell you that if there are more than one teacher, or if there is more than one course instructor in a course, like say for logic, or say for discourses in human values, we have more than one faculty member who is teaching or taking the course. It is the duty of a student to be very much acquainted with what the other teachers are also teaching. Like I, with my absolute amount of honesty, can try to teach you everything which I know about that subject, and I do. The same is done by all the faculty members, but still something skips out of our mind, or something we forget, or something we feel like that we have already talked about but it was not comprehensively dealt, and therefore some students may feel like that this topic was not covered adequately in this teacher's class, but it was adequately covered in some other teacher's class. So, and now since we all are on the online platform, already the two lectures are online, you can go through them. So it is my duty to tell you, and it is also my request, that every student should follow, not only those students who are in my class can definitely follow my lectures, but they should also, and nobody is stopping you from, they should also follow the lectures of other faculty members as well concerning a subject, because that brings more clarity and that gives you more understanding of how certain things are grasped or understood. Moreover, every teacher is having a very different way of dealing with things. Some teacher will take a few topics before and then they will go to a later topic. I will take some topic before and I will go to some other topic at a later venue. So these things also help in understanding that how we need to follow, or what should be our strategy of covering the syllabus. So that was my request. So please take care of that. Now, as you can see that today, the first question which has come to our mind, that after covering the two lectures, we have known about truth and falsity, we also know what are arguments, we also know how to find whether something is right or wrong, or correct or incorrect, all these things. So how we define logic? Now logic, there is a concept called logical pluralism as well, where kind of thing which is right or wrong in some concept may be wrong or right and in some other concept as well, so or in some other logic as well. But introductory, from an introductory point of view, we need not be very much worried about all these nitty-gritties or all those jargons and so on which logical studies are associated with. Especially from 2005 and on, there is this concept of logical pluralism, where people say that the same thing can be true or false in two different logic, and there can be more about it, and more deliberations follow. But all these things are at one place. For an introductory course, you need not worry about it. So for today's lecture, the first thing which we are starting with is, what is logic? Now this question comes to our mind. Okay, so I have four possible options for this question. The first is study of truth or falsity. Like logic is concerned with the truth or falsity of a statement, right? Or the truth or falsity of, in some books people also say the truth or falsity of an argument. However, we do not follow that convention, as I already told you. So for us, statements will be true or false, and arguments will be valid or invalid, and especially deductive arguments. When we will talk about inductive arguments, so it will be strong or weak. So the first thing, the option is the study of truth or falsity. So is it the now the question is that you have to choose the most appropriate answer, right? There can be more than one answer correct in a question. We will be adequately informing you about that as well. But right now here, I guess so there is only one answer which is right. So we will deliberate upon that. The second is study of argument. That logic is basically the study of arguments. That means it talks about correct reasoning and incorrect reasoning and so on. Then there is the study of right or wrong, whether something is right or something is wrong. Mostly many studies in philosophy or many studies talk about whether it is right or whether it is wrong to do something, whether it is correct or incorrect to do something. This right or wrong is a little bit different from truth or falsity. Truth and falsity is associated with statements. However, right or wrong is an act. Usually people talk in terms of acts. Or it is all the above. That means both, or say all the three, option number 1, option number 2 and option number 3 all are correct. Therefore we are saying all the above. So I can give you a second to stop this video and check whichever answer you will like to click on. Now let us come to the answer. Okay, you can stop the video and come to this part a little bit later so that you can check with my analysis. Logic is the study of truth or falsity. It is not the right option. This is not the right option because logic is not concerned with, and as you have seen in the notion of validity or invalidity, that we are more concerned with the form or the structure of an argument, right? Logic is the study of arguments. Definitely it is the right answer. Why it is not the study of right or wrong? Because it is not concerned with any act, right? So we are not dealing with any kind of act or so on, and therefore this option and this option also goes out of our picture. Now what is, now if you see logic is basically reasoning. Logic is reasoning. In many books it will talk about that it is a way to differentiate good reasoning from bad reasoning, or from cogent reasoning to incogent or non-cogent reasoning. There are different books which will pronounce it in different way. But simply speaking, if you say, logic is concerned with the nature of arguments, with the how an argument is formed. As you know that the building block of logic is nothing but an argument, right? So logic will always be concerned with the argument, and inside that there will be premises, there will be conclusion, there will be a claim that how the premises or how the conclusion follows from the premises and so on. So you need to understand this, that logic is the study of argument. Now these arguments can be of different types. Therefore there are different types of logic. People study fuzzy logic in computer science, first order logic, second order logic in mathematics, deductive logic, inductive logic in philosophy. In linguistics, people study different types of logic. There is something called paraconsistent logic. There is something called non-classical logic. There is so many types of logic, like the logic which starts from Aristotle. We will discuss about, our course concerns a little bit of that as well, is called Aristotelian logic and so on. So there can be different ways of logic. If you open a document in Stanford Encyclopedia of Philosophy, you will find entries on logic, not less than 50 entries in logic. So there are different types of logic, right? And that is the way. But any of these will be concerned with at least the commonality between all those logics will be one thing, and that is that it is the study of arguments. So you need to understand that logic concerns arguments. It is a form of reasoning. Okay, so as I discussed that these are the topics which we are discussing today. So the first topic which we will be discussing is truth functionality. The second is simple statements or propositions. Then we will go to compound statements or propositions. We will also talk about logical connectives, and at the end of the discussion we will take the respective truth tables of the logical connectives. That will be the third part of the lecture. So let us come to truth functionality. Now what is truth functionality? There will be definitions. There can be definitions of truth functionality, that this is how the truth functionality is defined. A proposition is true or false, how you determine it, or how the truth functionality of one proposition is defined. But Those things you can find it in the book, you can find it in the lectures, in other discussions as well, and you will find a lot of things like this in internet as well, from a common language understanding, because this class is meant for clarity, right? What is truth functionality? Let us understand. But before that, the truth functionality of something, like what is a truth function? Let us try to understand what is a simple statement and what is a compound statement. So let us understand first thing, that what is a simple statement and what is a compound statement. So once we will be clear with these ideas, then we will be very clear with the truth functionality as well. But truth functionality is basically the heading of these things. So let us take a simple statement. That what is a simple statement? Now you might be aware of that anything, whenever we call something simple, so one way of understanding is it that it cannot be further broken. Now it cannot be further broken into what? This becomes a question, right? Like something is simple, it means that it cannot be further broken, or it cannot be divided again, right? So again, in order to understand a simple statement, let us come to a compound statement first. So compound statement, I'm writing compound statement because I will deal with compound statement first. What is a compound statement? Compound statement is a combination of simple statements. So simple statement cannot be further broken. That means, like suppose we started this course with an understanding like what are letters, what are words, what are sentences, what are statements, and so on. Like if there is a statement, statement like today is Wednesday. Fine. So if this is a statement, I refer it as P. So what I define P as, that P is today is Wednesday. Fine. And Q, if I define, if there is another statement that today is Mahashivratri. Fine. Now there are these two statements. So I can conjoin these two statements together. If I say P and Q. So what will be the statement? The statement will be today is Wednesday and today is Mahashivratri. Another way of saying it will be today is Wednesday and Mahashivratri, right? So this is a compound statement. Fine. But when we break it into its compounds, or when we break it into its constituents, it becomes a simple statement. So simple statement, like now if suppose you can say that this can be further broken, like if I say today is Wednesday, can I break it like today, Wednesday? You can break it, but then it will not form a sentence, or it will not form a statement. There can be at some point of the time some kind of statements which can be further broken into sentences, different sentences. I'm not saying that it cannot be broken, but is it a statement? If it is statement, if you remember what is a statement, the statement is either an assertion or a denial, right? We talked about this. So when we say that something is a statement, it will be either an assertion or denial. You can see that these two are assertions. In fact, any simple statement is basically an assertion. If you negate it, if you deny it, then there is I can say that it is not a simple statement anymore. Why I am not saying, or why we will not consider it to be a simple statement anymore, is something which we will be discussing in logical connectives. So allow me to come to this part and then we will understand. But right now you can have an idea that any statement, any simple statement will basically will be an assertion. So it is an assertion. Like today is Wednesday is an assertion. Today is Mahashivratri is also an assertion. Whether it is true or false does not matter. Fine. P and Q. right? Today is Wednesday and today is Mahashivratri is a compound statement because it is the combination of simple statements. Fine. And a simple statement like today is Wednesday, you cannot further break it. Today will not make any sense. Wednesday will not make any sense. I know Wednesday makes a sense. We understand that it is a day of the week, but it is not a statement. Wednesday is not a statement. If I say today is Wednesday, it's a statement. If I say tomorrow is Wednesday, it's a statement. If I say yesterday is Wednesday or yesterday was Wednesday, it's a statement. The cricket match took place on Wednesday, it's a statement. Fine. So I'm asserting something. But if I say Wednesday, it's not a statement. Fine. So that needs to be understood. Now today is not going to be a statement. Today is not making any sense, or you are not asserting anything. Today is what? Today is something, then it will become a statement, whether it is true or false. So this is the idea of what is a simple statement and what is a compound statement. A simple statement cannot be further broken into any constituent part which will be an assertion. And compound statement can be further divided into combinations of simple statements. So this is the idea. From a very basic way, you will find many definitions in book. He has written that, she has written that about what is simple statement or what is complex sentence. Sometimes this compound statement is also called as complex statements. So that terminology can be also used. So first thing first, you need to understand that how a complex sentence or a statement has formed and how you can divide it into simple statements. So this is the idea of simple statements and compound statements. Now, a truth functional or truth functionality basically means that the truth or falsity of something can be derived, like truth functionality of a statement only we will be deriving. The truth functionality of a statement is derived through its constituent statements. So a way of defining truth functionality will be that anything which we where we need to find the truth value, like we have already discussed that a statement can be true or false. Now, how to determine the truth or falsity of this statement? Truth or falsity of a statement is completely inherent in the nature of this. Like if suppose today is Wednesday and if today is also Shivratri, fine. So today is Wednesday and today is Mahashivratri will be a true statement because I am stating it in this way. But suppose if today is Wednesday but today is not Shivratri, so one part is true but the other part is false, so this will make the statement also false, that you will say today is Wednesday and today is Shivratri. So I know that today is Wednesday but today is not Shivratri. Fine. So I will say that, oh, this statement is not true. But how? What, this statement is false. How we are determining it? We are determining it by the truth value of these things. So truth functionality basically says that if something is truth function statement, so its truth functionality or say in very layman terms, the truth or falsity of it is derived from or is coming out from its constituents and nothing else, nothing from outside. You do not need to worry about anything. So these are very basic concepts, very basic things, not much to be worried about, but you need to have an idea about it. We will move to the next part. That means, look, we have covered this part, we have also covered this part, we have also covered this part. Now let us come to the logical connectives, which is going to be a very important part for our truth functionality determination. Fine. What are logical connectives? Now, as you can see that I, in the last example, took P and Q. Fine. So we took P and we took Q as two statements, right? So usually P, Q, R and so on, these are used for statements. This is the language of logic. So in language of logic, like in algebra, we use X or Y or Z for any kind of assumptions. Similarly, for any kind of assumptions in logic, in deductive logic, usually the capital letters are used, but sometimes you will also find these small letters. So this can also be used. We will come to these things as well in a later stage, but again, these are conventions. It's not something very sacrosanct about it, that you need to follow the capital letters or you need to follow the small letters. it's not very much. You can also take alpha, beta, gamma if you are very well versed with the Greek letters. So you can take alpha, beta, gamma as well. There is absolutely no problem. You need to just define them. So usually we will take P, Q, R as these statements. Now these statements in itself will not make much of logical sense unless we have a way to connect them. That is what we call as connectives. Now in logic, in this course, we will be using the following convention. Like, you must be aware of this sign. This sign is basically used as negation. In our book, you will find this sign. This is like negation. So this is the sign for negation. So I am telling you the signs or the logical connective. So this is a negation. So if like P says that today is Wednesday, so negation of P will say today is not Wednesday, or it is not the case that today is Wednesday, right? So this is negation. Now there is another sign which you are very well versed with in your mathematical discourses. This is conjunction. In our course, we use a dot for conjunction. So it is like an AND function, right? So it is conjunction, it is an AND function. So if today is Wednesday and today is Mahashivratri, so P and Q. So we will be using this sign. Then you also know about this sign. It is an OR connective, right? So in our book or in our course also we use the same signs. It's called wedge. And this is basically a disjunction. So this is a disjunction, right? So we use it for either or just or kind of thing. Now we have, you must be aware of, again, there is a sign called this. It's basically a function of if then, right? In our course we use this horseshoe. It's called implication. So implication or material implication, these are the terminologies which is used for it. And then you must be also aware of this sign which is called equivalence. So in our course we use this sign, triple bar. Triple bar is for equivalence. Equivalence or material equivalence we call it. So if you see the name of these things, so this sign is called as tilde or tilde. Okay, this is a conjunction sign. It is basically called as a conjunction sign, but this is called as a dot function. So it's not the dot function which we use in mathematics, but the dot function for conjunction. Now this is called as wedge sign, or it is also called as well. So well or wedge is basically this V kind of symbol for disjunction. Now if you come to this is an implication. This is called as horseshoe. So horseshoe sign is basically used for implication, and this is called as triple bar. So triple bar is for equivalence. So if you see, these are the names: the tilde, the dot, the wedge or the well, the horseshoe or the triple bar for negation, conjunction, disjunction, implication and equivalence respectively. So these are the signs for if we have to connect, say, P, Q, R and so on. How to connect them? We will be connecting them with these logical symbols. Sometimes they are called as logical symbols, sometimes, but usually they are called as logical connectives. Basically it's the part of symbolization, so sometimes it is also called as symbols, but an apt explanation will be that it is a logical connective. These are logical connectives. These are basically propositions. So mostly in our course we will be using this terminology proposition rather than statements. Statement is more like from the linguistic way of looking into things. Propositions are more like looking from the logical point of view. So I hope we make enough of sense with these things, and these are the logical connectives. And now we will learn how simple propositions are turned into complex propositions with the help of these symbols, and we will also understand the truth tables of these. Okay, so we will start with the truth tables. The first truth table which we will take is the truth table of negation, that is the tilde truth table. So how to define, if you remember, I said that if something is P, then what is the value of negation? It's the simplest of all the truth tables, and you can see that I am only taking P as the connective. So if the value of P is true, so the negation of P value will be false. So this is quite clear with the understanding that if suppose a statement is true, then the negation of that statement is going to be false. And if a statement is false, then the negation of that statement will be true. So this is the simplest table, and there is nothing much to discuss or nothing much to understand about it. So I remove this table and quickly move to the next table, that is of two simple statements, and we will use a connective over here. We will use a connective over here, and we will see what will be the function. I need not define how a truth table is constructed, because you are well versed with all these things, and you must be very much aware of the conjunction, the disjunction, because as we study, you also know about that. Like this was basically the NOT gate. So you also know about the AND gate, you also know about the OR gate, you also know about the NAND gate as well as the NOR gate. So all these things are something which is known to you. You may not be aware of the implication as well as the equivalence, so we will discuss. But let us start with conjunction first. So if you see, we will put the dot mark, that is the sign of conjunction. So for conjunction, if P is true and Q is true, so we know that the conjunction is going to be true. In rest all the cases, the answer is false. This is something which we all know, because it's more or less like a series connection, right? So if one is closed and the other is open, so one is closed and the other is open, so the current cannot pass. So this is something the understanding, you all know about it. So in order to make this bulb glow, you need to put both the things on the closed understanding, that is the truth understanding. So if any one of them is open or both of them are open, so the current does not flow. This is the basic understanding which we usually use in mathematics or electronics and so on. So also in computer science. So this understanding is very clear. So this is the truth table of conjunction, we all know. Now let us come to the truth table of disjunction. So I remove these values, the rest of the values will remain the same. So I need not prepare or construct the truth table again. So we put the wedge mark. Now here also we know that when both the functions are true, it is true. If any one of the function is true also, then it is true. But when both of them are false, then only it becomes false. So in this case, when both the functions are false, it is false, or else it is true. Quite contrary to the conjunction understanding, when both of them are true, it is true, rest of them are false. Here, when both of them are false, it is false, the rest of them is true. The only commonality is that false breeds false in both wedge and conjunction, and in this part it changes, this remains common, right? So this thing has to be clear. It is basically a parallel circuit understanding. It's like this, right? So if any one of them is closed, the bulb is going to glow. So that understanding, you know, if the current is passing through this or this, so it can pass through here, it can pass through here, it can pass through both, but if both of them are open, then it is going to be false. So this understanding. So we are very clear with this, and we know how to prepare this. Now we will come to something which you may not be very clear about, and that is the truth table of implication. So let us take the horseshoe. Now if something P is true and Q is true, say if P is Q, then Q is true. This is the statement, so it is true. If P is true but Q is false, then it is false. If this is false, this answer is going to be true. Now this is the truth table. Now this is a very interesting truth table and very confusing sometimes you find it very confusing that how it is the case. When these are true, then absolutely there is no problem. But and when this is true and this is false, it's also fine. It's something which makes it clear. Now this and this does not. In fact, this is also quite clear. If this is false and therefore this is false, therefore it is true, it's fine. If this is false and still it is true, then it is going to be true. Now mark my words for it that this is the heart and soul of logic as well, because the heart and soul of logic lies with the implications truth table. It's a very interesting thing. I will ask you to remember 3 things which I will say for validity. I will be proving it at a later stage. You know the definition of validity. We understood the definition of validity as if there is no substitution instance which can make the premises true and conclusion false, right? So this was the definition of validity. If there is no substitution instance which can make the premises true and the conclusion false, then the argument is valid. This is basically the nature of validity, right? If the premises are true and the conclusion is true, the argument is valid, fine. If the premises are true and the conclusion is false, the argument is going to be invalid, fine, it is not valid. If the premises cannot be true together, irrespective of the fact what is the nature of conclusion, it will always be a valid argument. Now this sounds quite counterintuitive, and as I told you that logic initially makes certain counterintuitive claims. Logic is not very natural. Truly speaking, it does not come naturally to human mind. It comes with learned enterprises. It comes with a lot of rigor. It comes with a lot of studies that you understand the nature of logic, how logic follows. It's not very natural. You need to first understand, delve deep into this. Now, in order to understand these things, maybe I will give you a couple of statements more so that you remember that how validity or invalidity is going to take place. But before that, allow me to remind you that validity is a formal notion. It is concerned with structure. It has nothing to do with the meaning of it. We are not concerned with the meaning right now. Now, 2 more ways of defining validity are, like this is the first definition of validity, definitely. The other 2 definitions of validity I will just tell you, or how to determine a valid argument and an invalid argument is something which I am telling you. As soon as we will be taking questions, and we will be taking a lot of questions, we will be taking a lot of problem solving sessions. Those sessions can be more than 1 hour long as well, because we will be taking a lot of questions as well. So in that, after solving a lot of questions, you will understand why I am saying these things. So for the time being, just mark my words, later on we will be establishing them as well, because right now our arsenal does not consist the kind of weapons which we require in order to understand these things, but these things should be at the back of your mind for better clarity. Like, an argument is valid. I will say an argument is valid if, the second condition, if the conclusion is a tautology. So this is the first thing which you should remember. If the conclusion is a tautology, like if suppose there are P1, P2 up to Pn and there is conclusion. If this is always true, right? Tautology is like always true. So irrespective of the fact what the premises are, this argument is always going to be valid. Okay? Third condition. If the premises are inconsistent. Now what does it mean? Inconsistent. If the premises cannot be true together, that means P1 is true but P2 cannot be true. If P1 is true, then suppose if P1 and P2 are of the value like P1 and P2's value is negation of P1. Okay, so they can never be true. If P1 is true, then P2 will be false. If P1 is false, then P2 will be true, and so on. So if the premises cannot be true together, that is what is meant by inconsistent. Fine. So if the premises are inconsistent, if the premises cannot be true together, then what will happen? The argument will again be deemed to be valid. Okay, so this is like the condition. In fact, the fourth condition which I will add is that if the conclusion is a tautology, then there is no need for premises even. Now this sounds also very like I have been defining for the first 2 lectures that an argument is valid when there are premises. Like, what is an argument? An argument is containing premises and conclusion. And now I am saying that if the conclusion is a tautology, then there is no need for premises. So you will understand that tautology in itself is a combination of premises and conclusion in one way, or one way of understanding it. Or validity in itself says that the premises implies how validity is checked. If you see all these P1, P2, Pn, like P1, then and, P2, then and, then P3, and up to Pn. If you take this value and then you put an implication sign and then you put the conclusion, the whole value should come as T or tautology. So I will come to all these definitions, but right now telling you just for basic understanding that this is the heart and soul of logic, that how we derive actually. This is deductive logic. In deductive logic, you need to divorce yourself from the understanding of semantics, or from the understanding of the meaning of the proposition, or the meaning, or how one thing is meant to say something, and so on, and more concentrate on the structure. Like in computer science and electronics also, if you see, we are more concerned with the structure. If the structure is not right, there will be a syntax error, right? So you need to concern yourself with the structure. Logic is concerned with the structure. Once you clear the robust structure, then if you put meaningful entities also, the answer will be very meaningful. Even non-meaningful entities can also come out with some meaningful. That is the jargon, that is the paradoxical situation which we come to in logic, but does not matter. Do not worry about all those things. You need to get the logic right. And how to get the logic right? To get the logic right, you need to understand the structure. This is basically the structure of a valid argument. Then when you conjoin all the premises together, and then you put an implication sign, and then you put the conclusion, so the value of this has to come as a tautology. We will understand. We will take exercises in truth tables and so on. So you will understand that how these things are generated. Anyways, so this was the understanding of validity and so on. But we are left with one more truth connective, and let us define that before we finish the class for today. And that is the truth connective or logical connective, which is called as equivalence. So how equivalence is defined and how the equivalence truth table is drawn is something which we are taking. So we will remove this and all, and let us come to the equivalence. So P equivalence Q, right? So we have P equivalence Q. So in that case, if both the values are same, then the answer is true. If one value is one thing and the other value is another thing, in this cases it is false. This is equivalence. Equivalence says that if this is equivalent to this, then the answer is true, right? So it is true. The rest of them is false. So this is about the truth function connectives. In next class, we will talk about interdefinability, that how one symbol can be defined in another symbol, and how few basic truth tables we will also draw, that how truth tables can be drawn, and what are the cautions which we should keep in our mind, how we find a tautology, how we find a contradiction, and so on. So I hope that you have understood all these concepts. Study them practice. Then you have the book. We have already referred to you the book. You can also see the relevant exercises and start solving the questions before you come for the next class. Thank you.